This is 2H, forces on inclined planes. So it says Angelo and Carlos are asked to determine the relationship between the normal force on a box of mass m and the angle of incline of the box theta as the box sits at rest. That's important, right? Because at rest means zero acceleration, which means the sum of the forces is equal to zero on the incline. So first thing they want you to do is a free body diagram for the box there. And they have included here a little dash line to indicate the incline right there. So first thing here is gravity, as always, acts down. So we'll add that in there. So I will draw gravity down like that and label it here the force of gravity, or you could call it mg or w for weight. We clearly will have the normal force, and remember normal means perpendicular, so the normal force will go up like that, so I'll label that N for normal force, and then we will have here, it is sitting still, so the force of gravity will want to pull it down the plane, but it's not going down, so we must have some friction here back the other way, like that. And I will label this friction. So, now that's all you want to do on there. They explicitly say do not put any components on here. But I'm going to go ahead and do it, just so we can talk about the other forces involved here. So again, you would not actually want to do this on your sheet, but we're going to need to do this later. There is a part of this, force of gravity, that is perpendicular to the surface. So when we do it like this, we get a perpendicular part right there. And I'm going to call that force of gravity perpendicular to the plane. And then we are going to have another force of gravity that's in this direction here that is parallel to the plane. And so I'm going to call it that, and I'm going to call it right here. Let me get it lined up. So that component is parallel to the plane. So we can call that force of gravity parallel. Lots of books will call this force of gravity Y, which I often do too, and force of gravity X. Okay, so the next question says here, start with Newton's second law and derive an equation that relates the normal force with the angle of incline. So for each line, write the mathematical statement and then write out your description. I'm just going to say the description to save us time. So they began with this. The sum of the forces in the y direction is equal to the mass times the acceleration in the y direction. Well, it's not accelerating off of or into the plane. So our next line can be, this is basically 0. So we can write this. The sum of the forces in the y direction is equal to 0 because the acceleration in the y direction is equal to 0. Next thing, let's think about sum of the forces means add up all those forces there. So let's look here. The y direction, or what we could call the perpendicular direction here, we have two of them. We have the normal up and the perpendicular component of gravity down there. So let's write this. We have the normal force up minus the force of gravity perpendicular. And those two add up to be 0. So I will just move this to the other side. And this is really kind of obvious from the beginning, that the normal force and the force of gravity perpendicular must be equal to each other because no one's winning there. So let's substitute in then for what the force of gravity perpendicular is here. So whenever you have an angle like this, and actually I sort of flip these on the side here when you're drawing these, this angle here is always the same. So the angle down here, which they're calling theta, is always the same as this angle right here, which is theta. So the force of gravity perpendicular is the adjacent side to the angle, which means we're going to use the cosine function there. So here, let's write the next line. The normal force is equal to the force of gravity times the cosine of the angle. That will give you the perpendicular side. And then let's just expand this out. The normal force then, the force of gravity is mg cosine theta. And there we're done. This is always true. These two always equal each other on an inclined plane. So this statement is always true as well. Every single time you have an inclined plane problem. So the next thing is, I can get these apart here. They say Angela and Carlos then perform an experiment to test the equation that they derived in part B. The following data are collected. So they've got all these different normal forces here, and they've got all these different angles that they have there. So maybe they like put the thing on a scale, and that would measure the normal force as they tip the scale up. So part C says, based on the equation you created in part B, what data should be plotted to create a linearized graph for this experiment? So remember, what we plotted on the other page, or what the equation we got on the other page was the normal force is equal to mass times gravity times the cosine of the angle. So we want this to look like a line equation. So let's think about it here. This can be our y then. So we'll put normal force on the y. But what about angle? Well, it's cosine of the angle here. So what we actually want to do is make all of that dx. So we want to put all of that as our x there, cosine of theta. And so that means that on our graph, actually, if we wanted to sort of create it here, if we did normal force on the y and cosine of the angle on our x, then we would get a straight line like that, because we'd have a y equals mx, not m as in mass, just as in slope. So what would be the physical meaning of the slope? Well, the slope would be everything else left over, which is this. So the slope would be mass times gravity, aka the weight, or FG, whatever you want to call it.